Hello everyone, myself this is Pavan, second BTech IT, belongs to CC Institute of Technology and Engineering. Here I am submitting a video assignment on Floyd Warshall algorithm under supervision of G. Nageswara sir. I am very excited to discuss about Floyd Warshall algorithm. Firstly, what is Floyd Warshall algorithm? The Floyd Warshall algorithm is for solving all pairs of shortest path problems. The problem is to find the shortest distances between every pair of vertices in a given edge-weighted directed graph. It is an algorithm for finding the shortest path between all the pairs of vertices in a weighted graph. The algorithm follows the dynamic programming approach to find the shortest path. Given a weighted directed graph, u, v, t, x, z is a path of weight 29 from u to z. U, v, w, x, y, z is another path from u to z. It has weight 16 and it is the shortest path from u to z. This is the example for shortest path algorithm, also known as Floyd-Warshall algorithm. Problem: given a weighted directed graph G, find the maximum and find the minimum weight path from a given source vertex S to another vertex V. Shortest path is equal to minimum weight. Weight of path is sum of edges. Example: a road map. What is the shortest path from Chapel Hill to Carlotisville? More shortest path variance. All weights are non-negative. Weights may be negative but no negative cycles. A path is a path from a cycle is a path from a vertex to itself. Negative cycles allowed. Algorithm reports infinity if there is a negative cycle on path from source to destination. 2 and 3 seem to be harder than 1. Here the shortest path variance from the Floyd-Warshall algorithm. Floyd-Warshall algorithm, dynamic programming solution that solves the problem in order of V cubed time. Negative weights edges may be present. Assumption: no negative weight cycles. Intermediate vertices for Floyd-Warshall algorithm. Without loss of generality, we will assume that V is equal to 1, 2 and so on, and that is that the vertex of the graph are numbered from 1 to n. Given a path P is equal to 1, 2 and so on m in the graph, we will call the vertices k with k in 2, and so on m minus 1. The intermediate vertices of P. Remarks also there for Floyd-Warshall algorithm. Let us say remark 1. A shortest path does not contain any vertex twice, as this would imply that the path contains a cycle. By assumption, cycles in the graph have a positive weight, so removing the cycles would result in a shorter path, which is impossible. Let us see remark 2 for Floyd-Warshall algorithm. Consider a shortest path P from I to J such that the intermediate vertices are from the set 1, and so on k. If the vertex k is not an intermediate vertex on P, then dij power k is equal to dij power k minus 1. If the vertex k is an intermediate vertex on P, then dij power k is equal to dik power k minus 1 plus dkj power k minus 1. Therefore, we conclude that dij power k is equal to minimum of dij power k minus 1, dik power k minus 1 plus dkj power k minus 1. Recursive formulation for Floyd-Warshall algorithm. If k is equal to 0, then dij power 0 is equal to w of ij. If k greater than 0, then dij power k is equal to minimum of dij power k minus 1, dik power k minus 1 plus dkj power k minus 1. This is the algorithm for Floyd-Warshall algorithm. Time and space requirements for Floyd-Warshall algorithm. The running time is obviously order of n cube. However, in this version, the space requirements are high. One can reduce the space from order of n cube to order of n square by using a singular AD. Let us see example for Floyd-Warshall algorithm. At each step, k, dij satisfy the criteria. Path design set I and n at j. Intermediate vertices on the path come from the set 1, 2 and so on k. And step 1. Consider all paths which contain 1 as a intermediate vertices. 2, 1, 3 is an only path and we will find the using the formula. We will finding the path using the formula. In this case, we will find the dij, and then to find 2 2 3 3 3 2 2 3 3 2 2 and so on. Step 2. Consider all paths which contain 2 as a intermediate vertex. 3, 2, 1 is the only path. Again we will repeat this process using the formula. Step 3. Consider all paths which contain 3 as a intermediate vertex. 1, 3, 2 is the only path. We will obtain the value of an optimal solution. To obtain the actual solution, that is the shortest path between each pairs of vertices, use the predecessor matrix. This is the final result for we consider the example in Floyd-Warshall algorithm. This is the predecessor matrix. This is the another example for Floyd-Warshall algorithm. We will find the D1 P0 P1, D2 P2, D3 P3. Use this final predecessor matrix to obtain the optimal result. This is the program for Floyd-Warshall algorithm to print the shortest path between vertices of I and j. This is the total example for Floyd-Warshall algorithm you will see in this slide. Thank you for watching this video.